Well, here we can see the back of my 50-watt laser machine, and today I'm going to have a go at replacing the laser tube. Now, I can't really say I'm going to show you how to replace the laser tube because I don't know. I've never done it before. There certainly doesn't look to be too much involved, just a few water connections and a couple of high voltage electrical connections, so it should be a pretty simple job. Well, the first thing that I've done is drop my water tank down onto the floor, and in doing so most of the water has already drained back into the tank. I can see that there's still some residual water left in the tube itself. A bit of a blow through the tube should remove, I would think, probably 95% of the water from the laser tube, so that when I take it off it isn't going to run everywhere. Now, at each end of the tube there is a water connector. I'm going to be very careful because I don't want to break any glass, so I hope with a bit of luck, if I'm careful about how I do this, with a little bit of pulling on the tube and a little bit of pushing with my fingernail, look, the tube has just come off beautifully. I don't know whether the tube that I've got will have this connection on it already. We shall have to wait and disconnect the tube at the other end as well. Similar sort of arrangement. I should be pulling the tube and at the same time pushing it with my fingernail. Now, there's going to be a tendency for that tube to drop back and disappear inside the machine, so what I'm going to do is just put a tie wrap around these two pieces. There's a clamp on this end here. The screw at the back is a bit difficult to get to, so maybe with a long electrical screwdriver. There's a slot as well as a Phillips head. Can just about tease it out. I think there's a nut underneath there, which makes life very difficult. So we will just persevere with this for a minute and see if we can get the nut to fall off, which we have now. So I should be able to lift this cap off, and we've got to do the same at the other end. I'll lift this one off as well now, which I can. At this point the tube should nearly just lift up. And by the way, the machine is already disconnected from the mains. Now, this high voltage connection here has got a piece of silicon rubber sitting over the connection, and then it's been filled down the inside. It looks like silicon rubber material. When they supplied the machine, they supplied this pack of what they call silicon adhesive sealant, which I presume is this white stuff here. So we shall need to remove this tie wrap, and then we've very carefully got to try and remove. I don't know whether it will peel off or not. Depends how good the adhesive. Oh yes, it will. Yes, I can peel that off. That's good news. This is the water hose, and this is the same material as the water hose, so we could always nick an inch or so off one of our water hoses to make a new fitting. Now, it would be nice to see how they're fixed. Oh, nothing too special. I would have thought that would have been soldered on there. But as you've just seen, I've pulled it off, so I can't believe that that has been soldered on there. But there's enough cable there for me to cut that off, make a new joint, and I will finish up soldering it onto the new unit. Okay, as you can see, I'm holding this wire, so I'm not dead yet, so I think it's okay. So we shall now carefully try and remove the tube from the other end, which we can do. So the tube is actually pushed over the glass stem here. Let's have a look, see what they've done this end. Have they managed to solder it on this end as well? Oh my goodness me, no, look, it is literally just, it's literally just twisted on. Unbelievable. And now that all the electrical connections are finished, or they're removed, the tube just comes away. Now I'll just go and find the replacement tube. And here's how the replacement tube arrived. It came all the way from China in a tri-wall cardboard box, heavily packed with foam rubber, as you can see. When you compare these tubes, the construction at this end is completely different. Maybe 2 inches longer, but that's not a problem because it still fits in the case perfectly okay. Right, so we shall remove this one, and we'll put this one back in its place for the moment. Now, the bad news is that this laser is slightly bigger diameter, the one that was there before, and as you can see, it sits a lot higher at this end So that's a problem I'm now going to have to think about how I'm going to resolve. Let me unplug my water in and my water out. So I'll also temporarily remove my extraction system. Remove it out of the work area completely. So yeah, that tube is too big, so the only way that I'm going to be able to get that tube to drop down 1/4 of an inch, which is what it's got to go, I've got two choices really. One of them is to take this whole bracket assembly off and split the block down the middle and allow it to just open up a little bit, because we've already agreed that this top half will flex enough, but I've got to get these holes to line up, and this is a very stiff bracket. This one hasn't got any flex in it. Or what I could do is I could cut this bracket off about here and just clamp it on with the front clamp, because the front clamp would probably still hold the tube in place. It's only got to be stable. It's not as though it's going to travel halfway around the world again. I've just got to hold the tube in the right place so that it remains permanently lined up with the mirror. Now I can assure you that if my wife was out here at the moment, she'd want to know what on earth I was doing messing up a machine, because I should be invalidating the warranty. Well, I think I've already done that, so let's just have a little bit of courage. Just make sure we don't cut that wire. There we go. That wasn't too difficult. So let's take a look again and see what we've done. No, it's still about 3 millimeters up in the air. Well, I suppose there's no reason why I can't take it all off, because by the time I put this top bracket on here, which will be clamped from one side only, so that's what I think I'd do. I might have to put a spacer in there to hold it like that, but that will then lock the tube up nicely. I've got a little rotary burr on the end of my Dremel tool. We don't need to carve it off completely. All we need to do is just take away the excess material here. And that will effectively make the radius bigger. So that's probably the easiest solution. Now I shall need to do the other one as well, otherwise the tube will sit very slightly at an angle while I'm trying to fit it. Take courage in both hands and modify both brackets. The end is still not quite going down, but the end looks like a perfect fit, so we've just got a little bit more tweaking on this end here. Okay, well the good news now is we've managed to get the tube sitting nicely flat on the bottom of the bracket there, so it's as low as it will go. But I can see when I look on the end here that this piece of aluminium is a long way out of line with the mirror. Here I am looking from above, and you can see again that this is out of line with the hole in the mirror. So it's got to come across this way, probably at least maybe 1/4 of an inch as well. It's because the tube is basically stable in there. Look, I mean, I can move it from side to side and it doesn't. It's locked in there. So all it needs is some sort of pressure on the top to stop it from physically rotating or moving. And I should be able to achieve that probably by cutting this bracket off at about that point there. So that's Junior Hacksaw into action again. I think all I need is a small spacing washer in there. Okay, well I've now removed the nuts from underneath here, and it's allowed these brackets to lift up, where I can now remove one of the spacers. Right, I've just done a couple of quick measurements, and this tube here is 6 millimeters bigger than my previous tube, than the old tube. So if I'd have left this existing block in there, it would mean that the centre has risen up by 3 millimeters because the tube is 6 millimeters bigger. And as you can see, the block is 8 millimeters. So that really means that what I've got to do is to pack this tube up So it was 3mm high. I've taken 8mm out, so it's now 5mm low. That means I've got to put a 5mm spacer in there. An M5 nut is say 4mm, and an M5 washer is 1mm. So if I put a washer and a nut underneath here, then I will be able to lift this block up by 5mm, and it should come back to the same height as it was before. As you can see, what I'm going to do is just put a washer on, then I'm going to put a nut on, and I'm going to do the nut up so that it is just not even finger tight, it's just slightly looser than finger tight, so that the whole assembly will slide backwards and forwards in the slots. And do the same at the other end. I'm just putting the nuts on first very quickly and loosely, because these screws will have a tendency to fall out if I'm not careful, so that's why I was doing that. And once I've got the nuts on, I can just tighten them up to the right degree of tension. So I should be able to pop those through the holes now, like that. I would say that looking at that, they're still slightly high actually on the mirror, but having said that, they must be where they were before. The centre must be on the same point as it was before. So we will carry on and we'll leave it like that. I put the nuts back now, finger tight, and that will hold the screws upright. We've got enough slack on there that we can afford to lose an inch of that. So I think we'll cut a piece off and then we'll strip 5/8 of an inch, 3/4 of an inch. This post is going to be a little bit difficult to solder, I think, so the first thing I'm going to do is to clean it up. If it's not shiny, then it's still got oxide on it. And while it's nice and clean and shiny, let's see if we can tin it. Let's put plenty of solder on there to start with to get a fairly rapid heat transfer. The solder is just rolling off. So all I can do is to cut this off again and give myself more to wrap round there on that post. I'll split this into two sections. Maybe the right thing to do is to wrap one of these sections round anti-clockwise, like that, and then this section round clockwise. There were 7 strands on that cable, so what I've done, I've broken it up into 4 and 3, and I've done a twist on it to start with so that it's tied on, but then I've taken the tails and I've wound 3 of the tails clockwise and 4 of the tails anti-clockwise to produce that. It's not soldered on, so presumably what that glue is for. It gives insulation and helps to fix it into place so it can't come off. So I've got 2 new pieces of silicone tube. That one's very convenient because it's upright. Then we'll run some of this adhesive into it. Yeah, I'll just get a tie wrap and give it a little bit of assistance. There's some adhesive around the joint. I will now turn that down so that it can't come off anyway, because it's going to be sitting down on the deck with this piece at the top. Let's just put this tie wrap on here because I seem to remember that's how it was fixed on before. Well, I'm not going to stand there and hold it, so let's put a bigger tie wrap around there just to hold it while it's drying. There we go. Now hopefully that'll keep that in place while the glue dries. I don't think it really matters how far the tube is away from the mirror, but there are times when you want to get in there to do a mode burn test, so I'm going to leave myself about an inch of gap there. So what I haven't done is lock these up at the moment. It's still floating, as you can see. So I will line that up by eye with the centre of that, and we will tighten up the nuts underneath. Right, but the important thing is when it's all tightened up to make sure that it doesn't move in any way from side to side. Connect in our water supply, turn our laser off to start with. We'll turn the water pump on, and here we can see, check the other end, bubbles still coming through. Well, any bubbles that are coming through are going straight out. which is good. There are no dead spots in this tube. There was a dead spot in the previous tube.